Hi everyone, it's John from Practice Problems with John. It's our first video on the channel where I'll just pretty much be solving practice problems in high school math, physics, first year university, calculus, and physics as well, whatever you guys want. I just found that there wasn't a lot of problem solving on YouTube. There's a lot of explanation videos, so I just want to go through practice sheets, practice exams, etc., and just hopefully I can be helpful. If you guys have any content that you want me to cover, you can send me an email in my email description or leave a comment below. Please like and subscribe if you enjoy the video so I can make more. Today we'll be covering some grade 12 advanced functions. This is if you live in Ontario, Canada, this course would be MHF4U, but the information should be universal. So this is the worksheet that we'll be working on today, and if you guys like it, I'll make other worksheets on other content in the course. Thank you and enjoy. Other videos on the other units. The first question we have here asks for the factored form of the function. Because this is a third degree function, we can't use the factoring methods like the quadratic formula and other methods taught in grade 10, and we'd have to use something called polynomial division. For polynomial division, we need to find the first zero by ourselves by making educated guesses, and then we'd use that zero and use polynomial division to find the rest of the zeros. And there would be 3 zeros overall because it's a third degree function. And by educated guesses, I mean is right off the bat, you can tell that the zero can't be at x equals 0, because if you sub in 0, you're going to get -2, and you can just tell because you have this negative d term at the end. So another educated guess I'm going to make is it's 1. Usually 1 is a nice number because you can just look at the coefficients. So f of 1 would be 1 cubed plus 2 times 1 squared minus 1 minus 2, and that's equal to 0. Therefore, x equal 1 is, fix that, is a factor. And in order to convert this into factored form, you would do x minus 1. And the reason that works, it's kind of more lower level math, but the reason that would work is because 1 minus 1 equals 0. Therefore, you just use the inverse sign of whatever x you solve for. Now we have to do polynomial division using x minus 1. So we're going to use our function x cubed plus 2x squared minus x minus 2 divided by x minus 1. Let's just double check the function there. Yeah. And the way you would do that is you would divide the first term by the first term here, and then you would multiply out and pretty much treat it like normal division. So what I mean by that is, so x cubed divided by x is x squared, and I like to keep things lined up, so I'd kind of put like a 0x cubed here, and then this way it's just easier to follow. So x squared times x, so you're going to subtract the difference here, x squared times x is x cubed, minus x squared, and then plus 0x plus 0, and then this way every term kind of has a term to deal with. X cubed minus x cubed is 0x cubed, and then 2x squared minus negative x squared is 3x squared, negative x, and then those would just stay the same, so minus x minus 2. And then you would do the same thing again, so 3x squared divided by x is equal to 3x, so plus 3x, and then you would subtract, so you would get 3x times x is 3x squared minus 3x plus 0, and then that would cancel out, so you get 0x squared, negative x minus negative 3x is 2x, and then minus 2, and then you would do that one more time, so 2x divided by x is 2, so 2 times x, so that'll be 0x squared. And then 2 times x is 2x, and then minus 2, and that will give you 0, and that's kind of what you're looking for. If you do get a remainder, it means you either your factor is wrong or that you did not divide properly, because the whole idea of finding the factor initially is that you do not want to have a remainder. So now we know that f of x is equal to x cubed plus 2x squared minus x minus 2, which is equal to x minus 1 multiplied by x squared plus 3x plus 2. And now we just need to factor this term here. And in order to do that, we can use the grade 10 methods. And because this has a value of a equals 1, which means that there's only one x squared term, it's not like 2x squared or 3x squared, we just need two numbers that multiply to 2 and add up to 3. And that's pretty easy because 2 on 1. So you're going to get x plus 2 and x plus 1. So therefore, f of x is equal to x minus 1 multiplied by x plus 2 multiplied by x plus 1, and that should be, go back up here, c. So yeah. Okay, so moving on here, we're going to do the next three questions because they're just kind of, they depend on each other type of thing. So question 2 is the easiest one because the y-intercept is at x equals 0. So question 2, y-intercept is x is equal to 0, which we actually can already solve. So you just sub in 0 in the equation. So f of 0 is going to equal to 0 cubed plus 2 0 squared minus 0 minus 2, which is equal to negative 2. Therefore, yeah, the answer is A. Because, yeah, so the y-intercept is 0 and negative 2. As for the x-intercepts, those are the factors. So from part 1, we got the f of x is equal to x minus 1, x plus 1, and x, I believe, plus 2. Therefore, the x-intercepts are when y is 0, so intercept y is equal to 0. And in order to kind of do that, so if you think about it this way, in order for me to get a 0 on this side, I need one of the brackets at least to be a 0. So for the first bracket, 1 minus 1, and that'll be 1 plus 1 and 1 plus 2, and that would give me a 0, so therefore x is equal to 1. And the way to kind of solve this is you just inverse the sign in the bracket. So therefore, x equal 1, x equal negative 1, and x is equal to negative 2. Those are the x-intercepts, and more properly, it would be x-intercepts 1 and 0, negative 1 and 0, and negative 2 and 0. And that answer would be plus minus 1 and negative 2, so that's B. Now, as for the factors of, let's solve question 4 here. So as for the factors of f of x, it's literally just what we solved for here in part 3. So it would be x minus 1 is a factor, x plus 1 is a factor, x plus 2 is a factor. So technically all those answers are correct. And for the x squared minus 1, well, actually x squared minus 1 is equal to x minus 1 times x plus 1. It's an example of the difference of squares, where if you multiply two factors by each other, but they have the different sign, you're going to get the first term squared and the second term, subtracting the second term squared. So it would be like a minus b multiplied by a plus b is equal to a squared minus b squared. So that's just a good piece of information to know if you don't already know that. So then that answer would be E. Okay, so moving on here to question 5. This one's the same as question 1, but they're telling you what to divide by, and since x minus 3 is not a factor as we solved for, we know we were going to get a remainder, so automatically 0 is off the table as an answer. So I'm just going to I'm going to write the function again, x cubed plus 2x squared minus x minus 2, and we're dividing by x minus 3, so we're just going to set up our polynomial division, x cubed plus 2x squared minus x minus 2, and then this is x minus 3, and we're just going to divide by the first term, so x cubed divided by x is x squared minus x cubed minus 3x squared plus 0x plus 0, and that's 2x minus plus 3x, so this is going to be 0 plus 5x squared minus x minus 2. 5x squared divided by x is plus 5x, so, and then that's minus, and we're going to do 5x squared. 5x times negative 3 is negative 15x plus 0. And that's going to be 0x squared. Negative x minus negative 15x is going to be 14x, so plus 14x minus 2. 14x divided by x is 14, so plus 14 minus 14x minus 14 times 3, which would be 42. So that's going to be minus 42. Negative 2 minus negative 42 is negative 2 plus 42, which is 40. So as you see here, we did get a quadratic at the top, which is we expect, but the remainder is not 0 because x minus 3 is not a factor, and the remainder is 40, so the answer is D. Okay, so moving on to question 6. The average rate of change from x equals 0 to x equals 1. So since it's the average rate of change, the formula is pretty much the same as a slope formula from grade 9. So that would be AROC, which is average rate of change, is equal to y2 minus y1 over x2 minus x1, which is equal to f of 1 minus f of 0 over 1 minus 0. Here it's, let me just fix that there, 1 minus 0. Okay, so f of x is equal to x cubed plus 2x minus 2x squared minus x minus 2. F of 1 is equal to, I believe, 0, which is, yeah, it's going to be 1 plus 2 minus 1 minus 2, which is equal to 0. F of 0 is equal to negative 2. Therefore, AROC is equal to 0 minus negative 2 over 1 minus 0, which is equal to 2 over 1, which is equal to 2, and that is E. Okay, so we're back here with question 7. So here for this one, it's asking for the instantaneous rate of change, but considering that this course is done before calculus, most of you don't know how to take the derivative, so you'd have to kind of do it using the average rate of change method. The key here is that you want to do it with a point really close to 0, and usually do it to a couple of points and try to see what number you're approaching. And since it's a multiple choice question, there's no decimals here, you can kind of make a really good guess by doing that. So I chose 0.1, 0.01, and 0.001. We'll see if we need all three. Some teachers may ask you to do like negative 0.1 to 0 and so on, and some may ask you to take the average of those answers. So it just kind of depends on what you're expected to do, but for multiple choice, it doesn't really matter. So what I'm going to do here is just the same thing. So I'm just going to do AROC1. 1 is equal to f of 0.1 minus f of 0 over 0.1 minus 0. And that's going to equal f of 0.1 minus negative 2 over 0.1. And on the side here, f of 0.1 is equal to, I'm just doing that on the calculator, would give us negative 2.079. Okay, so you just sub that back in. So negative 2.079 plus 2 over 0.1 is equal to negative 0.079 over 0.1, which is equal to negative 0.79. Next, so that's, I guess, we can kind of already make the estimate that it's going to be -1, but we'd rather double check it and get closer, especially if it was a word problem. You're not going to be like, oh, it's negative 0.8, that would be wrong, and you don't have enough information to make the assumption that it is -1. So again, we're just going to do AROC 2, which is equal to f of 0.01 minus f of 0 over 0.01 minus 0, which is equal to f of 0.01 minus negative 2 over 0.01. And on the side here, f of 0.01 is equal, let me just put on the calculator. Yeah, that's negative 2.01. I'm actually getting 0.0097, so I can just round that to negative 2.01. And that's going to equal here, so negative 2.01 plus 2 over 0.01 is going to equal to negative 0.01 over 0.01, which is equal to -1. And since we kind of already got the answer here, I don't need to do the 0.001 part. I'll probably get the exact same thing again. So -1 is the answer, and that would be C. All right. Okay, so moving on with question 8. It's asking for the solution when f of x is equal to 12. The way you get a solution is you make one side equal to 0. You know that from grade 10 math. So we do f of x, we know it's just x cubed plus 2x squared minus x minus 2. And then we're just going to put 12 here. So 12 is equal to x cubed plus 2x squared minus x minus 2. And we're going to move the 12 to the other side. So that's, we have a 0 on one side. That's going to equal to x cubed plus 2x squared minus x minus 14. And we wouldn't need to fully factor it because we were not asked for all the factors. So we just need to find that first number that makes it 0. We already know that it can't be 0 because we have this negative 14 that's not going to go away. It's not going to be 1 because we can already tell it will be 1 plus 2, which is 3 minus 1, which is 2. 2 minus 14, so that would be -12, so that wouldn't be it. So we can just kind of take this one off. So one way to go about this is to just sub in the rest of the answers. So let's just start with 2. So f of 2 would equal to 2 cubed plus 2 times 2 squared minus 2 minus 14. And that would equal to 8 plus 2 times 4 minus 16. Which is going to equal to 16 minus 16, which is equal to 0. So just right off, the answer is x is equal to 2. Okay, so question 9, essentially to solve the inequality, they want the range or the domain where f of x is above 0. And the reason I use the word domain is because f of x would be y, so you need the x range, and the x range is the domain. And we know that f of x is equal to 0 at x is equal to 1, -1, and -2. So I can kind of draw my number line here. I have -2, I have -1, and I have 1. And then this is all 0, 0, and 0. The thing is we don't know in like this range right here, and this range, and this range, and this range, whether it's above or below 0. So a good thing would be to get rid of those. Yeah. So a good thing would be to substitute numbers in those ranges and see what we get. So for example, we would try a number less than -2. So that would be f of -3, which would equal to -3 cubed plus 2 times -3 squared minus -3 minus 2, which would equal to -27 plus 2 times 9 plus 3 minus 2, which is equal to -27 plus 18 plus 1. So that's -27 plus 19. That would be 8, I believe. Yeah, -8, exactly. So -8. So that we know that f of x is negative before -2. So this is a negative range. We can now try a number between -2 and -1. For that one, we would put, let's say, -1.5. So f of -1.5 is equal to -1.5 cubed plus 2 times -1.5 squared minus -1.5 minus 2, which is equal to, I'm going to use a calculator for this one. So, and that gives us 0.625. And this is a positive number, so we know that this range is above 0. Now we need something between -1 and 1. I like to just put 0 in there. So f of 0, and that's just equal to -2. We know that from the 10 times we've used it before in this question. So that would be a negative number here. So that range isn't correct. And now we need a number bigger than 1. So we'll try f of 2, which is equal to 2 cubed plus 2 times 2 squared minus 2 minus 2. And that would equal 8 plus 8 minus 4, which is equal to 12. So therefore, this range is positive. And now, going back, we know that it's positive between -2 and -1. And the square brackets include the range, and it said bigger than or equal to 0. So we know that -2 and -1 would be included. If it said just bigger than 0, we would put rounded brackets. So this answer right here is wrong because it uses the rounded brackets. And then the other range would be 1 to infinity. So we're including the 1 to infinity. And infinity, it doesn't matter if you use the square or the curved. I always like the square because I guess we're including infinity, but it doesn't matter. So then that would put us at B. That would be the answer. And this union in the middle is just kind of means like an and, or includes both ranges. So -2 to -1 and 1 to infinity. Okay, so moving on to question 10. This one's a bit of a weird one, so I'm gonna, because we're not allowed to use any calculus methods in this course, I'm just gonna show you two ways to solve this problem. One is more algebraic, and the other is kind of, it'll help you get the answer in a multiple choice. So we know that, we know that f of x, oh, it's acting up on a second here, yeah, is equal to x cubed plus 2x squared minus x minus 2. And in this case, they want x at the limit, it's pretty much called as x approaches -infinity. one way you can do it, the first way, is you can sub in a really, really large number that would resemble negative infinity. For example, negative 10,000. So if you did f of negative 10,000 and you put that in the calculator, so negative 10,000 cubed plus 2 times 10,000 squared minus negative 10,000 minus 2, you would get, I got it right here, negative 9.99 times 10 to the 11. And this is a really, really large negative number. And you can kind of insinuate that this is negative infinity, which would be the answer. The other way, my preferred way, because to prove it algebraically, would be to factor out an x cubed and see what happens. So f of x is equal to x cubed plus 2x squared minus x minus 2. If I were to factor out the largest degree here, so I would get x cubed, I would have 1 plus 2 over x minus 1 over x squared minus 2 over x cubed. And anything divided by infinity or negative infinity is going to be 0. Like 1 divided by 10,000 or 10 million, that's a very small number. It's 0. So if I were to sub in negative infinity here, f of negative infinity, I would get negative infinity cubed multiplied by 1 plus 0 minus 0 minus 0. And that's going to equal to pretty much here, I would just have the 1. So I know that the number will exist. The trick here is because it's negative and cubed, you know that it remains negative. If this was a power of 4, it would be a positive answer. So negative infinity cubed is negative infinity. And that's the answer, negative infinity. So you just want to be aware when you're using this method to just keep track of your power, because it might change the sign of your answer. So again, 2 methods. The answer is negative infinity. Okay, so final 3 questions here. And for those 3 questions, I'm going to refer to the little table that we did in question 9, where we assessed the behavior at the zeros. So if I were to just kind of draw this into a graph here, and I'll put my negative 2, we know that before negative 2, the function was below 0, and after negative 2, it was above 0. But whoops, that's a bad, yeah. But we know that at negative 1, the function went below 0 again. So we know that there must be a turning point here because it has to be there. And at 1, we know that after 1, we know it has to come back and hit 1 and then go above 0. So based on that, we're able to see that there has to be 2 turning points in the function. And that would be our answer for question 11. Now for question 12, it's asking us what is the range of y values? Well, we know that there's no turning points before negative 2. So we know that the function would probably keep going to negative infinity. And after here at 1, we know that the function is going to keep going up and it's probably going to go to infinity. So the range is negative infinity to infinity. The function is not limited in any way in terms of its y values. So negative infinity to infinity, that would be our answer for question 12. And question 13, we already kind of solved it. And I'm just going to kind of eliminate why some of these are wrong. So this one is wrong, E, because it's not hitting 0 at negative 1. So that can't be right. This one, it's only hitting 0 at 2, but it's not hitting the other zeros, and actually 2 is not even the right 0. It's negative 2, so that's wrong. This one's wrong too. It has a 0 at 0 and 2, so that's not the right 0. Yeah, and actually they're all kind of wrong. There's not even a question here. So it's negative 2 to negative 1, we know that it's below 0, above 0, below 0 again, and then above 0. It's the one that resembles the graph that we drew, so the answer is D. Okay, so this is the end of our video. I hope you guys enjoyed and found this helpful. I'll be posting more worksheets in this course and the calculus and vectors course, as well as the grade 11 and 12 physics. If there's anything specific you want me to solve, you can feel free to email me or leave a comment below. Please like and subscribe and have a great day.